All right, so today, in the previous climate change lectures, we, always with the BB, with the previous lectures, we basically outlined the evidence for climate change, number one. Number two is we were going to test this ourselves to see if the temperature is actually increasing in areas of the country that were predicted to see an increase. So what we did is we picked 3 areas. Let's see, we did Yuma, Arizona, Fairbanks, Alaska, and Grand Junction. Is that correct? Okay, cool. We did the min and max. Basically, we took it at 10-year intervals. This is given up here. So this is for Miami. This is what Dr. M did. Thank you very much, Dr. M. So we've got all the temperature from June 1st all the way to August 31st. And these are the maximum temperatures for 1954, 1964, 1974, 84, and so on. Okay? I think the first thing we should do, and this kind of helps us look at the data, and this is really easy to do. What I want you to do is select all the data itself, just the data. Go all the way down. Okay, everybody do that? Okay, this is kind of a quick and easy way just to look at, how can I color this to make it so we're able to see it better. So go to Conditional Formatting, and you should see this color scales. I know yours is going to be a little different on your PC. Did everybody find that? Because I saw it on yours yesterday. You got it? Okay. Here's what I want to do is I want to make the data so that the higher values are red and the lower values are green, and everything in the middle is yellow. Okay? So I'm going to go here and pick this red, yellow, green color scale. Click it. All right, did that change everybody's colors? Mine's going to look a little different because I was informed that I actually have hidden columns, which I didn't know about because I made a rookie mistake. But so I've got some hidden like minimum values, and that's why you don't see a lot of green, but you can still see this kind of color change here. And we can actually, this might be interesting. So let's take this, select all these columns. Okay. Now what we're going to do is we're going to kind of put it like this. Did we do that? Oh, it just showed my hidden columns now. Hold on. Let me hide these again. Click hide. Okay, I think that's working a little better. Okay, everybody do that? Now this kind of makes it easier to see. We can, well, no, I say we leave it here. So just looking at the data, just based on colors. Remember, this is 1954, 64. This is going up. Does it look like it's getting warmer just based on the colors? A little bit, huh? What year, though, does look like it was pretty warm in the past? The first one, B, 1954. See, look at this down here. This is a little warm. I would say this is a little warm, but you can tell it does look like it's actually increasing, right? Just based on the colors. Again, we're going to show this. We're going to prove this. Okay, I'm going to expand this again. It's going to probably unhide my stuff. Okay. So the best way, I think, to try to understand data is to see it. That's kind of what I'm about. I'm a simple person. I like to see the data. If I see a line that's higher than another line, then I can say, hey, that's probably different. So here's what, well, first off, let's do the averages. Let's go all the way to the bottom. Okay, so in column, your last column, let's go average. Okay. After that, let's go put a SD. We'll make that standard deviation. Okay, everybody got that? Okay, so for this one, or do we want to put a median in there as well? Let's do median as well. So insert a row here and go median. Okay, so we're going to do this. All we have to do is do it for one column, and then we can drag it, all the functions over and get all that. So to find the average, go equals. Just type average is the easiest thing to do. And select all these numbers. Everybody do that? So we're taking the numbers B3 through B94. Everybody got that? Hit return. Okay, now median equals median. Same thing. You could actually type those numbers in there, or you could just select all the cells. Shift, turn. Okay, and then now standard deviation. What's standard deviation again? Who knows what standard deviation is? In simple terms. Pre-med. Standard deviation. Remember we were talking one standard deviation, two standard deviations. What does that mean? Absolutely. It's kind of, it reflects the spread of the data. So if you had a high standard deviation, would you expect a wide hill or a skinny hill? Yeah. You would expect a wider one, right? So the standard deviation is basically the measurements around the mean. It's basically the spread. The larger the standard deviation, remember this, the larger the standard deviation, the bigger the spread. The more data that fits in that 68% of the data, the bigger that, the wider that area is. Okay, and then standard deviation, let's do that one. I think you go standard dev. Yep, stdev, or you can find it on your functions, either one. Shift. All right, 3.3. That means that 68% of the data, or these temperature measurements, are going to fall between about 92 degrees and 96 degrees or 86 degrees. Does that make sense? And you can look at it and you can see that that's probably true for sure, right? So this is pretty tight data. Okay, now to do this for all the different years, I'm going to drag this over. Bam. All right, let's look at the average. 89, 88, 88, 87, 89, and then we're jumping into 91 and 90. So here we're kind of seeing a trend of increasing temperatures. Means kind of reflects that, but it's a little different. According to our calculations, which year had the, let me bring this down. Oops, wrong one. So what you can do if you want to see the top ones, and I'm going to spread these out a little bit. Oops. Okay. And what you can do is you can, I'd use this function a lot. What you can do is you can grab the top of here. You see that kind of two arrows on each side and the little parallel bars in the middle? If you pull this down, it'll keep your column headers at the top. Cool, huh? Did you know you could do that? What's that? So I took this here. So there's a kind of there's this bar here. You don't want to get on the very top. What you want to see are the two parallel lines. When you see that, just drag that down until you can see the labels. And now these labels will stay there as I scroll. You see that? Did you do that? Cool. All right. So based on our measurements here, which year has the highest, let me open this a little bit. Which year has the highest, or which summer has the highest average temperature? 2004, right. Which summer had the lowest? Which one? Was it 1984? Yep. Okay. Which year had the greatest variation in temperatures? Which had the largest spread of temperatures? 1954. Does everybody see why that's correct? Which was the most consistent summer? Meaning the temperatures, the maximum temperatures stayed around the same level. Which one? 2004. Yep, exactly. Okay, well, let's graph these. And so this is basically what I'm going to have you